Hi, I'm an old guy and I do maths. Today we're going to look at the long division of polynomials with remainders. Now the remainder is simply something that you're left over with after you divide a number, for instance. So let's think of something. Let me think. 13 divided by 12 is 1 with one remainder, that sort of thing. And the same is true of anything that you divide by anything. It's possible to get a remainder. So let's go to work. So our polynomial is x cubed plus 2x minus 3, and we're dividing it by x plus 1. Now, first thing to notice, there's no expression in here of degree 2. So we've got x cubed and then we go down to x to the power of 1. So when we set this up, what we have to do is we have to put a filler in here, 0x to the power of 2. And that keeps things nice and tidy. It also allows us to do this. And this is just like having a ones, tens, hundreds and thousands column when you were in primary school. Anyway, let's go to work. So we're dividing this by this. So first question, what do we have to do to x to get x cubed? Well, we multiply it by x squared, and that gives us x cubed plus x squared. And we subtract that. This disappears. 0x squared minus x squared gives us negative x squared, or negative 1x squared if you will. We bring down the 2x and ask ourselves the same question. What do we do to x to get negative x squared? And the answer is we multiply by negative x, and that gives us negative x squared minus x. And we subtract that, and this disappears, and 2x minus negative x gives us 3x, and we bring down the negative 3. What do we have to do to x to get 3x? Well, we multiply it by 3. That gives us 3x plus 3, which we will duly subtract, and we will get negative 3 minus 3, negative 6. Now, negative 6 is our remainder. And what does that tell us? First thing that it tells us is that this expression here, this linear factor, is not a factor of this cubic. So if we're looking for a factor of this cubic, we have to look elsewhere. Now, you will sometimes be a little bit baffled when you see what comes up next. So I'm just going to write the question out as it was set. And what this is equal to is this times this, x squared minus x plus 3, minus 6 over x plus 1. And this is quite often how you'll see remainders written. And all it means is that when you divided this by this, you got this, but this is left over. Well, the negative 6 was left over, and if we're going to write a proper expression for what x to the power of 3 plus 2x minus 3 divided by x plus 1 equals, we have to account for everything, and it is this times this minus this divided by this. Now, if we go a step further, if we were to multiply through by x plus 1, we'd get rid of these denominators, and we would be left with x cubed plus 2x minus 3 equals x plus 1, x squared minus x plus 3 minus 6, which is not a form in which you see this terribly often, but either of these statements is completely true, and I don't really know how important this is. I think that what's important from the point of view of someone, say, at high school who's learning long division of polynomials is how to deal with the remainder. So I guess that if you're asked what the answer to this is the form in which you put it. If you're asked what are the factors of this, then you would give an answer that looks like this. The important thing that I really want to stress is that when this number is not 0, this thing can't really be regarded as well. I suppose you could call it a factor at a stretch, but it's not the sort of factor that you're looking for. It's not something that divides evenly into this without leaving a remainder, and so you don't get something that's nice and tidy as a set of factors. Say, for instance, these two things. You've got something hanging on the end. Anyway, that is long division of polynomials with remainders, and with the added little bonus of having to put this filler in to cope with the fact that in this expression there isn't anything of the second degree. Okay, thanks for watching. I hope that was useful. See you next time. Bye.